Okay, welcome back everyone. Okay, so we will start our semester 2 by this week. Okay, so first we will learn electrostatic. Okay, so for electrostatic, there are 4 subtopics. Okay, so the first one is 1.1 Coulomb's law, 1.2 electric field, 1.3 is electric potential, and also the final subtopic is charge in a uniform electric field. Okay, so today in this video, we will learn the first topic first, Coulomb's law. Okay, so Coulomb's law states that the magnitude of the electrostatics, or sometimes we call it Coulomb force, or sometimes we may call it electric force. Okay, so there are 3 names here, either electrostatic force, Coulomb force, or electric force. Okay, between 2-point charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay, so if you want the electrostatic force to happen, at least you must have 2-point charges. Okay, at least you must have 2-point charges. Okay, so the equations that we use is F equals to K Q1 Q2 over R square. Okay, where your K is the constant value. Okay, electrostatic constant. Okay, the value is equals to 9 times 9 times 10 to the power of 9. Okay, so this is the value for constant. Okay, if Q1 and Q2 are charges. Okay, so continue. Okay, so if Q1 and Q2 are charges of opposite sign, okay, if let's say opposite sign meaning that positive and negative, okay, if let's say positive and negative, it will experience attractive force, okay. So meaning that if let's say positive and negative, satu charge positif, satu charge negatif, okay, both of them will attract, okay, mengalami daya tarikan. If Q1 and Q2 both positive or negative charges, meaning that both of them are similar charges. Okay, similar charges. If both of them are similar charges, meaning that you experience a repulsive force. Okay, so for example, positive and positive, negative and negative. So they will experience a repulsive force, daya tolakan. Okay, so SI unit for the charge is Coulomb. Okay, SI unit for charges Q. Okay, for charges is Coulomb. Okay, is Coulomb. This is the SI unit. Okay. So next. Okay, please note that the sign of the charge can be ignored when substituting into the Coulomb's law equation. Okay, so usually when you want to substitute into this equation, F equals to K Q1 Q2 over R square, okay, usually we modulus, okay, meaning that we just ignore the sign of the charge. So the sign of the charge is important in distinguishing the directions of the electric force. So usually we use sign of the charges to distinguish, to determine the directions of the electric force. Okay, so the sign convention for the charges is important to determine the direction. Okay, meaning that we want to know whether it's attractive force or repulsive force. Okay, so next, okay, we go to the example. Okay, here we have two charges. Okay, two charges Q1 and also Q2 are separated by the distance. So meaning that we have Q1, we have Q2, and we have the distance R. Okay, in cm. So we convert it become 0.04 meter. Change to unit SI. So sketch the electric force diagram. Okay, so sketch the electric force diagram on Q1 and Q2. Okay, Q1 negative, Q2 positive, meaning that it is a opposite sign. So it will experience a attractive or repulsive, negative and positive. So both of them will experience a attractive. Okay, it will attract to each other. Okay, menghampiri daya tarikan. Okay, it will go close to each other. Okay, so if this is Q1, Q2, we label it as this is F1. Okay, 1 attract by 2, and this is 2 attract by 1. Okay, and the distance separations between them, of course, is 4 cm. Okay, 4 cm, or we can write it as 0.04 meter. Okay, so this is the sketching for electric force between Q1 and Q2. Okay, so now find the magnitude and the directions of the electric force that Q exert on Q2. Okay, so the questions very important here is the question said they want to focus on Q2. Okay, Q2. So meaning that we are focusing on Q2. Okay, Q2 is like our superstar. Okay, so we calculate FQ2, meaning is 21 equals to KQ1 Q2 over R square. Okay, so we substitute all the value. K is the constant 9 times 10 to the power of 9. Q1, the value is negative 20 nano. Okay, Q2 is positive 90 nano. And the distance between them is 0.04, and remember to square. Okay, so the value that you get, okay, you can try to calculate first. So the value that you get is 1 times 10 to the power of negative 2 Newton. Okay, as I mentioned just now, the negative here not important, that's why we modulus. Okay, we modulus. Okay, with modulus. And why we modulus? Because we don't want to consider the sign, as we only want the magnitude. So the magnitude is 1 times 10 to the power of negative 2 Newton. But because force is a vector quantity, you must also give the direction. So now if you are referring to the force exerted on Q2, if you refer to the diagram, your Q2 is moving to the left. Okay, so it will move to the left. Okay, if next questions, the question asks, find the electric force that Q2 exert on Q1. So now Q1 is the charges that we want to refer. So actually your F12 is equals to F21. Magnitude actually same. Okay, magnitude same, because if you calculate the equation K, Q1, Q2, Q1, Q2, we are consider both charges. Okay, so what are the difference between two charges is, if you're referring to Q1, if you're referring to, wait, I change color. If you're referring to Q2, your Q2 is moving to the left. Okay, but if you are referring to Q1, your Q1 is moving to the right. Okay, so both actually the magnitude are the same. Okay, for Q1 and Q2, so we say the magnitude same, but the directions is different. That's why we put negative here. So negative here shows that the direction is opposite direction, in opposite direction. So the value that we get is actually 1 times 10 to the power of negative 2 Newton, magnitude same, but for electric force exert on Q1 will be to the right. Okay, so this is for questions example number 1. Okay, so when we have two charges, we only have one forces. Okay, next we go to example number 2. Okay, example number 2, we have 3 forces. So we have 3 charges. So when we have 3 charges, meaning that we have 2 forces. Okay, we have 2 forces. So we refers to questions. This one very important. Sketch electric force diagram on Q2, meaning that Q2 is our superstar. Okay, superstar. Q2 is the one that we want to refer. Okay, so Q2 with Q1, positive, positive. Okay, positive, positive, repel. So this one we label as, this one will repel. Okay, Q1 will go to the left, Q2 will go to the right. So we label it as F21. Okay, of course, this one we label FF12. Okay, now Q2 and Q3, positive and also positive. So positive, positive, Q2 will move to the left. We label it as F23. And of course, your Q3 will move to the right. Okay, F3 pushed by charge 2. Okay, so this is the forces. Okay, of course, if you want to refer also can, charge 1 and charge 3. Okay, charge 1 positive, charge 3 also positive. So we have another force, F3 pushed by 1, and this one also F charge 1 pushed by 3. Okay, but if you're referring to the questions carefully, sketch the electric force diagram on Q2 only. So meaning that we are only referring to Q2. This is the diagram that we are referring because they only mention Q2. So Q2 experience 2 forces. One by charge 1, another one by charge 3. Okay, so this is your Q2. Okay, so this is the electric force diagram on Q2. We are referring to Q2 only. Okay. Okay, next, calculate the magnitude. Okay, if you're referring just now, the questions example 1, we only have two charges. So 2 charges, only 1 force. But if you have 3 charges, you will have 2 force. The first one is F21. The second one will be F23. Kita ada 2 jenis daya lah. Okay, kerana kita ada 3 charges. Okay. So, B, calculate the magnitude and directions of the total electric force exerted on Q2. So, for this case, we need to find out the magnitude first. Okay. So, F21, and we moduluskan dia, we modulus. So it's K Q1 Q2 over R square. Okay, so you calculate first, and then F23. Okay, and we modulus because we don't want to consider the sign convention of the charges. So you substitute inside 9 times 10 to the power of 9. Q1 is the 2 Coulomb and also 4 Coulomb. Distance between them is Q1 and Q2. Distance between them is, if you refer back, is 3 cm. So we change it 0.03 square, remember? Okay, so you will get 8 times 10 to the power of 13 Newton. Okay, and F21, of course, is to the right. Okay, it's to the right. Okay, and then F23 is 9 times 10 to the power of 9. Q1 is 2 Coulomb. Sorry, this is suppose is 3. 2, 3, 2, 3. Okay. Okay, so okay, charge 2 is 4 Coulomb. Charge 3 is 6 Coulomb. And the distance separations between them is 5 cm, so we convert 0.05 square. Okay, so please calculator. Okay, if you press calculator, you will get 8.6 times 10 to the power of 13 Newton. And if you refers to your F23, it is moving to the left. Okay. Okay. After that, what should we do? Okay, you have F21 to the right and you have F23 to the left. Of course, we need to find, because they want to find the magnitude and the directions of the total electric force. So our F resultant will equal to F21 plus F23. Okay, but F21 we write positive, yeah, because it is moving to the right. Okay, but F23, if you're referring to F23, is actually moving to the left. So we should put negative, negative because it is moving to the left. Okay, so we total up 8 times 10 to the power of 13 plus negative 8.6 times 10 to the power of 13. Okay, negative here shows the direction is to the left. Okay, so the answer that you get is 6 times 10 to the power of 12 Newton. Okay, and you will get negative. Okay, so negative here indicate that it is moving to the left. Okay, so final answer is moving to the left. Okay, you may pause the video if let's say you cannot follow. Okay, you can stop or you can calculate first. Okay, C. Calculate the distance of Q2 from Q1 where the total electric force is equal to 0. Okay, so calculate the distance of Q2 and Q1 because just now when we calculate it's actually not balanced. Okay, because final the Q2 will move to the left. Okay, because left is 8.3, 8.6, but to the right only 8. So final answer, the Q2 will move to the left. Okay, so now if let's say we want to let our total electric force is equals to 0, the resultant force equals to 0, meaning that we need to adjust. Okay, Q1, Q2, Q3. Okay, so this is your Q1, Q2, and also Q3. Okay, so this distance we must adjust, so we let it become X. Okay, and then just now total distance between them is actually 3 plus 5 cm. Okay, 3 plus 5 cm. So we need to adjust. Okay, if let's say this is X, meaning that this one will become 8 minus X. Okay, 8 minus X, or 0.08 minus X. Okay, if you convert into meter. Okay, so now if you want to find F resultant, just now is F 21 minus F plus negative F23. Okay, so in order to get 0, meaning that your both F21 must equals to F23. Okay, magnitude of both of them must be the same. Okay, if let's say left hand is 10, right hand must be 10. That only equilibrium will achieve. Okay, if let's say left hand 11, your right hand also must 11. Okay, if let's say left hand 100, your right hand also must be 100. Okay, to achieve the equilibrium. Okay, seimbang. Okay, so F21 Q2 Q1 over R square equals to K Q2 Q3 over R square. Okay, so K we cancel, Q2 we cancel. Okay, so we substitute Q1 is 2 Coulomb. And the distance between Q1 and Q2 is X square. Okay, Q3 is 6 Coulomb, and the distance between them is 0.08 minus x. And remember, square. Okay, remember to square. Okay, so after that, you recalculate. Okay, you recalculate 0.08 minus x squared equals to 6x squared. Okay, so if you expand it and then you press calculator, you will get x equals to 0.029 meter. Okay, 0.029 meter. Okay, in order to achieve equilibrium. Okay, so example 1 and example 2 only involve one exit, only involve x exit. Okay, so if let's say involve x exit, we don't need to resolve it. Okay, we don't need to resolve because only involve one component. Okay, next we goes to example 3. Okay, example 3, it involve two components, two x and y exit. Okay, so first we refers to the question first. So there are 3-point charges. Of course, when we know when there is a 3-point charges, of course, we will have two forces. Okay, we will have two forces. Okay, so questions number 3A. Sketch the electric force diagram on Q1. So Q1 is our superstar. So Q1 is the charges that we are referring. Okay, so Q1 and Q2. Negative, positive. Negative, positive is a attractive force. So Q1 will attract to the right. Q2 will attract to the left. So we label it F1, 2. This one we label it F2, 1. Okay. Okay, next. Q1 and also Q3. Q1 negative, Q3 also negative. Negative, negative is will experience a repulsive force. So your Q3 will push, okay, tolak to upward, and your Q1 will push downward. So I label it as F1, 3. This one I label it as F3, 1. Okay. Okay. If let's say you want to refer Q2 and Q3 also can. Okay, so Q3 is negative, Q2 is positive. Positive, positive, it will experience a attractive force. So this one will go down, F3, 2, and this is going up, F2, 3. Okay, but if you're referring to the questions, the question asks us to find diagram on Q1. So we only draw Q1. We only focus on Q1, where Q1 will attract to the right, F1, 2, and it will repel to downward. So I label it as F1, 3. Okay, so this is the electric force diagram for Q1, because Q1 is the charges that we are focusing. Okay, we are focusing. So if you refer to this diagram, actually this diagram involves X component and also Y component. If let's say you resolve, okay, if you resolve it. Okay, so next, questions B. Okay, B, determine the magnitude and also the directions of the resultant force. So if you have this diagram, actually we can go back to semester 1, chapter 1, resolving. So when we have X1, we have X component, Y component, you want to find the resultant, usually we need to use 5 steps. Okay, so step pertama, step number 1, you need to find out the magnitude first for F12, F13. Okay, you find the magnitude first. F12, so it's equals to KQ1, Q2 over R square. Okay, remember we will ignore the sign because here we want to find the magnitude for F12 and also F13. So you substitute inside 9 times 10 to the power of 9. Okay, and then your Q1 is negative. So we modulus. Okay, so we don't need to put negative also, never mind. Micro is -6. Q2 is 3.7 micro. And the distance separations between them is 15. So it's 0.15. Remember to square. Okay, so press calculator. You will get 1.78 Newton. Okay, and then you also need to find F13, and we also modulus Q1, Q3 over R square. So 9 times 10 to the power of 9. Q1 is 1.2 times 10 to the power of 6, -6. Q3 is -2.3 micro. Okay, over distance between them is 10 cm, so 0.1 square. And we also will ignore the sign of the charges. Okay, so you better you modulus lah. Okay, so when you press calculator, you'll find out that you will get 2.48 Newton. Okay, 2.48 Newton. Okay, next. Now we already have the magnitude for F12 and also F13. So what should we do? Yes, now we need to resolve it into X and Y component. Okay, so you need to resolve it. So it's better we draw a table. Okay, so because we only have two forces, F12 and also F13. So this is X component, this is Y component. Okay, so what should you do is before that, you must find the angle first. Angle. Okay, so just now the question say this angle is 32. So if this is 32, meaning that this will be 58 degree. Okay, 58 degree. Okay, so based on this diagram, we resolve it. Okay, F12 only move, okay, if you refers to this diagram, okay, if you refers to this diagram, F12 only move to the left, okay, you only move to the left, only move to the left. Okay, so when only move to the left, meaning that we only have X component, so your X component is F12, okay, 1.78. Y component is equals to 0 because it only moved to the right. Okay, it only moved to the right. And we put positive because it's moved to the right. Okay, okay, next F13. Okay, so F13 here, it moved to the right and also it moved to the, okay, it moved to the right. If you resolve it, it moved to the right and also it moved downward. So F13, the magnitude for, if you resolve it, okay, if you resolve it, you will get 2.48 cos 52 degree. And because it's moved to the right, so we put positive. Okay, and it moves downward. Okay, downwards. So if move downward, we put negative 2.48 downward. So 2.48 sine 58 degree. Sorry, it's 58. Okay, 58 degree. Okay, then what should you do? Okay, you total up. You find the resultant for X component and also Y component. So if you add on, you will get positive 3.09 Newton for X component and negative 2.104 Y and Z. Okay, okay, step 3. Of course, you need to find the magnitude. Okay, so magnitude is F resultant equals to surd Fx square plus Fy square. Okay, so you will get 3.09 square plus negative 2.1 square. Okay, but after square, negative will disappear. Okay, so the magnitude that you will get will equals to 3.78 Newton. Okay, so this is only magnitude. Okay, step 4, direction. Okay, so how can we find the direction? Okay, we use tangent theta. Okay, so we use Fy over Fx and we modulus the value because we only want to get the basic angle. Okay, so the angle that you will get 34.2 degree. Okay, so this is only basic angle. Okay, next step 5, you need to sketch the graph. Okay, so graph, of course, you must refer back to the table. Okay, you refer back to your table. Okay, so your table here just now, you get x component is positive. Okay, positive x. Your y component is negative. So we know that the angle 34.2 is at 4th quadrant. Okay, or you can write as below positive x-axis. Okay, so that's all for this topic 1.1. Okay, thank you, class.